welcome all of you. Let us explore some questions for IIT Advanced in Chemistry in a topic called electrochemistry. See, there are two rules of the game. If a multiple answer question, if you are confident about all possible answers, you should attempt it. And if a numerical value question you feel is very lengthy and it costs you a lot of time, even if you know how to solve it, you should postpone solving it because the time given will be limited. You should be cautious. And you need practice. Also, you have to have thorough understanding of the topic in order to solve these questions. Don't be particularly seriously worried about the scores in the beginning. Usually in IIT Advanced scores will be a bit low. So, let us see some questions. Let us target to do 10 questions. When a galvanic cell starts operating with passage of time, any galvanic cell, if you allow it to operate, slowly the cell potential will go down. That we call it as cell is getting discharged. And according to Nernst equation, E cell is equal to, you can see here, E cell standard cell potential is equal to standard cell potential minus of 0.059 by n into log Q. Q is called log of product ion concentration divided by reactant ion concentration. If you take this Daniell cell, zinc is becoming zinc ions, copper ions are becoming copper. Zinc becoming zinc ion is a product ion, copper plus 2 ion is a reactant ion. So, log of Zn plus 2 concentration by copper plus 2 concentration. If the equilibrium achieved, that is equal to equilibrium constant log K. If there is no equilibrium yet, then of course this is called log Q. Q means reaction quotient. So, obviously, if the concentration of zinc ions is increasing, the cell is getting discharged. If you want to increase the cell potential, one way is decrease the concentration of product ion, that is Zn plus 2, increase the concentration of copper plus 2, according to Le principle. Therefore, you can see this. When a galvanic cell is starts operating, spontaneous character of the cell decreases, that is cell potential drops, cell gets discharged, true. A reaction quotient Q decreases, E cell increases, that is nonsense. Reaction quotient gets increases, cell potential drops, so B is wrong. Useful work obtainable from the cell, no, useful work obtainable from the cell will drop. And as cell stops producing voltage, Q is equal to K. This is what finally happens when the cell is dead. When cell is dead, obviously, the concentration of product ions and the concentration of reactant ions, they come into equilibrium and the log Q will become log K. So, question number 28 answer must be A and D. Let us look at some other question. The correct statement regarding reference electrode, generally to measure the electrode potentials, we use a standard hydrogen electrode. We pump hydrogen gas into a platinum block fitted with a platinum wire that is kept in a glass enclosure which is immersed in 1 molar acid solution. Notice that the standard hydrogen electrode potential we take as 0 because that we take as a reference. Instead of hydrogen electrode, well, you can also take calomel electrode. Probably you will be knowing what is calomel. Calomel is Hg2Cl2. In this calomel electrode, if it is for your information, it is not there in NCERT, but just we are looking at. This is a calomel electrode. Here, it is a glass container. Here you are putting some mercury metal, which is a liquid at room temperature, over which you put Hg2Cl2, on which you put a potassium chloride solution. And this is connected to solder bridge. You immerse a platinum wire in a glass enclosure which is in touch with it. So, the platinum wire which is in contact with HgCl2 and Hg indirectly is known as calomel electrode because Hg2Cl2 paste is called calomel. Now, in this standard, we can take this as an additional standard electrode. Here in this you can see there are two options. Mercury can combine with chloride ion while losing electrons. It is called as a anode reaction. Mercury chloride Hg2Cl2 calomel can gain 2 electrons to become mercury. So when mercury is gaining electrons, in order to form mercury from Hg to Cl2, it acts as cathode. If it is losing electrons, it is acting as anode. Depending on the neighbor, it can act as anode or cathode. Notice that the calomel electrode has a specialty. You are putting KCl solution. Based on the concentration of KCl solution, the calomel electrode may act as a cathode or anode. Notice that the cell is reversible. Cell reaction is reversible means it can act as if it is a gainer of electron, it can act as a loser of electron based on the concentration of your chloride ions. So the calomel electrode cell is taken an additional standard in addition to standard hydrogen electrode, and it can act as a cathode and anode. The direction of the reactions can be reversed by varying the concentration of chloride ion. So that is an idea. So let us try to answer this question. Conductivity is, this is question number 30 we are saying. Standard hydrogen electrode is used as a primary reference electrode is absolutely true. Calomel electrode is used as a secondary reference electrode is also true. And then calomel electrode, the direction can be reversed by varying the concentration of chloride ion is a fact. Generally we use a standard hydrogen electrode and a calomel electrode as a reference electrons. One is primary reference, second one is secondary reference. Others are not primary standards or reference standards. There can be a twin hydrogen electrode, but that cannot be used as a reference electrode. We use only She and calomel electrode usually. So we will look at question number 31. Indicate the correct statements. Conductivity cells have cell constant values independent of the solution filled into the solution. Yeah, cell constant is about the length of the conductor divided by cross-sectional area of the wire that is fitted in a conductivity cell. The L by A value, which is known as cell constant, remain constant whatever the solution you take, it is not going to change. So C statement is a fact. In electrochemical cell, a salt bridge is used to maintain the electrical neutrality because it will dispense the extra positive ions accumulated in anode compartment left side, and it will dispense the excess of negative ions accumulated in the cathode compartment. That is the purpose of salt bridge, you know. Instead of salt bridge, you can also use porous partition. See, Kohlrausch law is valid for both strong and weak electrolytes too. At infinite dilution, conductance offered by individual ions is not influenced by other ions. At infinite dilution, total conductance due to all ions is equal to the conductances individual ions algebraic sum. So C is true. The K denotes, K means, you know, specific conductance, denotes the K specific conductance decreases as you are adding water because the number of ions in 1 centimeter cube volume will decrease. However, the overall mobility of ions will increase, therefore molar conductance or equivalence conductance, overall conductance will increase. So for this question 31, A, B, C, D all are correct. Now we quickly see question number 32, which of the following statement is or correct. Well, you have to read the statements carefully. The conductance of 1 centimeter cube of a solution is called specific conductance. Obviously, you know that that is the answer. True. Specific conductance increases while molar conductivity decreases on progressive dilution is nonsense. That is wrong because number of ions in 1 centimeter cube volume will decrease on adding water. The limiting equivalent conductivity of a weak electrolyte cannot be determined exactly by extrapolation of a plot. Conductance against square root of concentration. That is the limitation of Arrhenius theory, you know. Therefore, definitely C is fact. Next, the conductance of metals is due to the movement of free electrons. Yeah, conductance of electrolytes is due to movement of ions. Conductance of metals is due to movement of free electrons is true. So, for this question number 32, obviously, the correct options are A, C and D. So, everything is possible. These questions require time. That is why they give few questions. Like in mains, they do not give too many questions. You have to have patience. When a concentrated solution of an electrolyte is diluted, what happens? When a concentrated solution of an electrolyte is diluted, the specific conductance decreases is true. Its equivalent conductance increases is also true. A is true, B is true. C is obviously wrong, you can read yourself. D meaningless. Therefore, only AB. Let us look at question number 34. This is more interesting. They can give you individual electrode potential values, standard reduction potential values. Fellow with a higher reduction potential can gain electrons from other metals. For example, Ag plus can happily gain electrons from zinc, copper and nickel. If you look at copper, copper can gain electrons based on its electrode potential value from nickel metal and zinc. The copper ions can gain electrons but not from silver. So if you use this logic, you can obviously see that for this question the valid options are very clear, sir. A is possible, and B is not possible, C is possible, D is impossible. Okay, sir? Notice in 3D series only for copper the C is impossible. For all metals like scandium, titanium, vanadium, chromium, manganese, nickel, zinc, the equation C is valid. Only for copper it is invalid because copper has a positive electrode potential. Now we are looking at question number 36. This is a question you have to try, sir. 2 amperes of current is passed for 16 minutes, that is 16 into 60 into 2, those many coulombs of charge maintained. Notice 16 minutes and 5 seconds, that is 16 into 60 plus 5. How much, sir? 965 seconds, 2 amperes through 1000 ml of 2 molar aqueous solution of copper sulfate using platinum electrodes. Then what statements are correct? You can see that this corresponds to the charge equal to how many Faradays, sir? 0.02 Faradays. That is equal to, it is equal to 1.2046 into 10 to the power 22 electrons. You can remember that 96,500 coulombs is always equal to charge of 1 mole of electrons. Here if you multiply 2 with 16 into 60 plus 5, 965, 2 into 965 is equal to how many moles of electrons? You have to remember the number of coulombs you have passed is 2 into 965, whereas 96,500 coulombs is equal to 1 mole. Using that logic, you can see for 36A is a clear-cut possibility. And B is obvious fact that for the passage of 0.02 Faradays of charge, you will be getting 0.02 equivalent weights of copper, which is equal to 0.635 grams. After the electrolysis process, when methyl orange is added to this residual solution, it gives yellow color. Methyl orange gives yellow color in acidic medium. The solution, can it be acidic after passing current? You have to see. If that is, notice methyl orange gives yellow color to basic medium. Methyl orange gives red color to acidic medium. The solution is becoming acidic as copper ions are going into copper metallic state. The H plus is produced. The solution will become acidic. Therefore, if I add methyl orange, solution will become red color. So, option C is wrong. Option D, the volume of oxygen liberated at anode is equal to the oxygen liberated by the decomposition of 56 ml of 2 volume H2O2. Do you know 2 volume H2O2 when decomposed for 56 ml, volume of oxygen you get is 56 into 2, 112 ml. And you know 0.02 Faradays will always give 112 ml oxygen. Therefore, option D is right. So, these are some questions which have more than one correct option. Try to solve such questions.